question. The standard electrode potential of copper is given. Calculate the electrode potential if the Cu2 plus molar concentration of Cu2 plus is 0.2 molar solution. So it is, what is E electrode? E Cu2 plus bar Cu is equal to E naught Cu2 plus bar Cu according to Nernst equation minus 0.059 by N log molar 1 by molar concentration of Cu2 plus. This is our Nernst equation. Now I can take Cu2 plus up. So it is E is equal to Cu2 plus bar Cu is equal to E naught Cu2 plus bar Cu plus 0.059 by N log molar concentration of Cu2 plus. I have taken it to the numerator, then this minus will become plus. Now, what is N value? What is the electrode reaction? Cu2 plus 2 electrons gives Cu. This is the electrode reaction. So N is equal to 2. E naught Cu2 plus bar Cu is given. This is equal to 0.34 volts plus 0.059 by N. N value is 2. Log molar concentration of Cu2 plus is 0.2 mole. 0.2 is 2 into 10 raised to minus 1. Log of 2 into 10 raised to minus 1. Now how will you find out log of 2 into 10 raised to minus 1? So log, this is 2, it is log 2 is 0.3010 and log A into log B is log A plus B. Log A is log 2. Log of 10 raised to minus 1 is minus 1 plus minus 1. Or you can take it as log of 2 into 10 raised to minus 1 is bar 1.3010. If you are taking like this, you cannot write this directly in the equation because for a logarithmic value, this part is negative and this part is positive. So you will have to make this completely either negative or positive. At such a number only we can substitute in an equation. So this value we cannot substitute. Then this means it is minus 1 plus 0.3010. This is what I have written. 0.3010 plus minus 1. That is 0.3010 So it is minus of 0.6990. So you will have to write it as 0.34 volts plus 0.059 into 0.6990 divided by 2. You multiply, then divide into 2 and here it is minus of 0. That is this minus and this plus, it will become minus. So 0.34 volts minus 0.059 into 0.6990 divided by 2. You divide with the 2, minus from 0.34, you will get the answer. Okay, so this is 1. Now the next question. A voltage cell is set up at 25 degrees Celsius using Al3 plus bar Al and Ni2 plus bar Ni. Al3 plus concentration is given 0.001 molar and nickel 2 plus concentration is given 0.50 molar. And you are given with the standard electrode potential of nickel and aluminum electrode. You will have to calculate E cell. Calculate E cell. Now how will you calculate E cell? So for calculating E cell, you will have to set up a cell. Now how to set up a cell? You are given the standard electrode potential of nickel and aluminum. Both are negative. That means both have a higher tendency to get reduced. So the one with a higher tendency to get reduced will act as the anode, and the one with both are having a higher tendency to get oxidized. So the one with a higher tendency to get oxidized we will use as the anode. The one with a higher tendency to get less tendency to get oxidized we will use as the cathode. Here which is having higher tendency to get oxidized? The one with a higher negative value. So we will take aluminium as the anode and nickel as the cathode. So how to represent the cell? First you write the electrode Al solid, then the electrolyte Al3 plus. What is the concentration? 1.66 volts. Then the salt bridge. Now the cathode compartment. First the electrolyte Ni2 plus. Concentration 0.50 molar. 0.50 molar. Then you have nickel solid. This is the electrode. So you have set up a cell. Now you have to write the electrode reaction. At the anode what is happening? Aluminium is oxidized to aluminium 3 plus. So Al gives Al3 plus 3 electrons. This is happening at the anode. Now what about the cathode? What is the cathode reaction? Cathode reaction is Ni2 plus reduction plus 2 electrons will get reduced to Ni. So this is the cathode reaction. Reduction is taking place at the cathode. Now here you see these 3 electrons here 2 electrons. We will have to make both equal. What to do? So you multiply this equation with the 2 and this equation with the 3. So it is 2Al gives 2Al3 plus 6 electrons. Then here 3Al nickel 2 plus 6 electrons will give you 3 Na. Okay? You multiply. Now you add these two. 6 electrons will give cancel. So now what is the N value? It is 6 because 6 electrons are either released or accepted. So what is our total cell reaction? 2Al plus 3Ni 2 plus gives 2Al3 plus 3Na. So our cell reaction we got. Now we will have to calculate E cell. What is E cell is equal to? E cell is equal to E naught cell minus 0.059 by N log molar concentration of the anode. What is anode here? Al3 plus. Now Al3 plus. And how many Al3 plus is there? 2 Al3 plus. So raised to 2 divided by cathode. Cathode concentration is Ni2 plus how many? 3. So raised to 3. So this is our expression for E cell. Now that is equal to E0 cell is E0 cathode minus E0 anode. What is E0 cathode? Minus 0.25 volts minus E0 anode is minus of 1.66 volts. Isn't it? So this is minus of minus is plus. Minus 0.059 by what is N value? N value is 6 log molar concentration of Al3 plus. What is Al3 plus? 10 raised to minus 3. 10 raised to minus 3 square divided by what is nickel 2 plus concentration? 0.5. So that is 5 into 10 raised to minus 1 raised to 3. Now that is equal to minus of minus is plus. So 1.66 minus 0.25 that is equal to 1.41. 1.41 minus 0.059 by 6 log. Okay. 10 raised to minus 3 square is 10 raised to minus 6 divided by 5 square, 5 cube, isn't it? 5 cube into 10 raised to minus 3. Now 10 raised to minus 3 and 10 raised to minus 6 will cancel. 10 raised to minus 3 there. Then 5 cube is 125. Yes. 10 raised to minus 3 by 125. This is log value of this you must get. So log of A by B. So it is log of 10 raised to minus 3 divided by 5 cube into 10 raised to minus 5 cube. So that is 125. Now how will you find out log of 10 raised to minus 3 by 125? Log A minus log B. Log A is 10 raised to log 10 raised to minus 3 minus log of 125. That is 10 raised to minus 3 is bar 3.000. 125. Log of 125 is 2.125. Log of 12.5. Log of 12.5 is 2.0969. 0969. So it is so bar 3 you have taken one this side, so minus 4, minus 2 is minus 6. So bar 6.9031 you will have to take it, this value here. There is, you cannot write bar 6.9031, isn't it? So what you will have to write this minus 6.000 plus 0.9031. So you have taken minus 5.0969. So it is 1.41 minus 0.059 by 6 into minus 5.0969. So you will get the answer. Minus of minus will become plus here. So you do it, you will get the answer. So this is the how the cell EMF is calculated. Now we are going to the relationship between the EMF of a cell and equilibrium constant. Now consider the cell reaction of the Daniell cell. Zn plus Cu2 plus gives Zn2 plus Cu. This is the equation for the Daniell cell. What is log Kc is equal to equilibrium constant? This is an equilibrium. What is log Kc is equal to molar concentration of Zn2 plus into molar concentration of Cu, product of the molar concentration of the products by product of the molar concentration of the reactants. That is Zn molar concentration of Cu2 plus. Right? Now, we have taken these are two solids, and the molar concentration of solids we will take as 1. Molar concentration of Zn is equal to molar concentration of Cu is equal to 1 because they are solids. So, Kc is equal to molar concentration of Zn2 plus by molar concentration of Cu2 plus. Now, take our Nernst equation for cell constant. E cell is equal to E naught cell minus 0.059 by n log molar concentration of Zn2 plus by molar concentration of Cu2 plus. This is the Nernst equation for the cell. Now when equilibrium is attained, the rate of forward reaction will be equal to rate of backward reaction. Then we say that equilibrium is attained. When equilibrium is attained, we have studied there is no change in concentration of the reactants and products. Then what happens if the change in concentration is 0? E cell will become 0. So at equilibrium, E cell will become 0. At equilibrium, E cell is equal to 0. If E cell is equal to 0, how can you rewrite this equation? E naught cell is equal to 0.059 by n log, what is molar concentration is then 2 plus by molar concentration of Cu2 plus, it is Kc, log Kc. So E naught cell is equal to 0.059 by n log Kc, or how will you calculate log Kc? Log Kc is equal to E naught self into n divided by 0.059. So log Kc is equal to E naught self into n by 0.059 will give you log Kc, and if you want to find out Kc, you take the anti-logarithm of this part, you will get the Kc. So you can calculate the equilibrium constant. So consider the Daniell cell. Consider the Daniell cell equation. This is the Daniell cell equation. Sn plus Cu2 plus in equilibrium with Sn2 plus Cu. Now what is equilibrium constant? Equilibrium constant Kc is equal to the product of the molar concentration of the products by the product of the molar concentration of the reactants, or Kc is equal to molar concentration of Cng2 plus by molar concentration of Cu2 plus. Now you take this 2 as since they are 1 molar concentration of zinc solid and copper solid, they are taken as 1. You can take Kc is equal to molar concentration of Cng2 plus by molar concentration of Cu2 plus. Now according to Nernst equation, E cell is equal to E naught cell minus 0.059 by n log Zn2 plus by Cu2 plus. Now at equilibrium there is no concentration change. Concentration remains a constant, then E cell will become 0. When E cell becomes 0, this equation will become E naught cell is equal to 0.059 by n log Kc, or log Kc is equal to E naught cell into n by 0.059. So you can calculate the equilibrium constant Kc. And log Kc is, you can calculate then Kc.